So on number 9, if you're confused with the fraction, all you have to do, remember an equation, you can do anything you want to an equation as long as you do it to the whole equation, both sides. So if you have a fraction, you could get rid of any fraction by multiplying everything by the denominator of the fraction that you want to get rid of. So if you want, you could take the top equation and multiply it all by 4, and it'll get rid of the fraction 3/4. 4 times 2x, that becomes 8x. 4 times negative 3/4, again, the 4 that you're multiplying by will cancel out with the 4 on the bottom. So the 4s, when you multiply them, they actually cancel out, and you end up with just a negative 3y. And then when you distribute 4 times negative 7, you get negative 28. So multiplying by 4 will give you that new red equation without fractions. And you could do the same for the bottom one. You could multiply this bottom one by 2, and it'll give you a new equation. 2 times x is 2x, right? 2 times x is 2x. 2 times 1/2, again, the 2 and the 2 down here, they eliminate, so you're just going to have a positive 1y left over. So you're going to have plus 1y, and then 2 times 0 is still 0. So now you could focus in on this red and blue system, and you could worry about canceling out either x's or y's. So looking at this red and blue equation system of equations, what's the easier option? Cancel out x's or cancel out y's? I guess they're both pretty easy, but yeah, canceling out y's is probably what I would go for. So I'm going to multiply this top equation by, actually I'm not going to multiply the top equation by anything. I'm going to multiply the bottom equation by what to cancel out y's?
3.
By 3. So when I distribute 3 times 2x, that's 6x. 3 times 1y, that's 3y. 3 times 0 is 0. And the top equation I'm going to leave the same. It's going to be 8x minus 3y equals negative 28. And then you could combine the lines. 8 plus 16, that's 14x. The 3y and the negative 3y cancel out, equals negative 28. To solve that simple blue equation, that one-step equation, let's divide by that 14. We will get the answer x equals negative 2. And once you have one answer, you could plug it back in to any equation you want. You could go for the original, or you could go for one of the modified equations, but since we've always done original, let's continue with that. I want to plug it into the bottom equation. The bottom equation reads x plus 1/2 y equals 0. So I'm actually going to put parentheses in place of x plus 1/2 y equals 0. And I am going to plug in the x value of negative 2. So I need to get rid of that negative 2. So I'm going to add 2 to both sides. I'll have a new equation that reads 1/2 y equals 2. So my final step here would be to multiply by 2 and multiply by 2 to get rid of that fraction. I will have my answer y equals 4. So the coordinate for this system, the solution, is negative 2 comma 4. Of course, if you had more time, you could plug in the x value of negative 2 right here, the y value of 4 right here, which would cancel out, and it should give you negative 7 as an answer. Now, even, I know I didn't assign number 8, but even this decimal one, it's not that bad. You could convert this 0.5 to a fraction 1/2. You could convert this to a fraction 1/2. You could convert this to a fraction 1/4, right? Or you could simply multiply the top equation by 10, which would move the decimal place over one spot. That would be a negative 20 right here if you multiplied everything by 10. You could multiply this by 100 if you'd like to change that to get a 25y. I would actually change them to fractions. Okay. So on number 8, if you were doing number 8, the 0.5 would change to 1/2 x plus 0.5y, that's plus 1/2 y, equals negative 2. The bottom equation would be x minus, see the 0.25, if you think about that, that's really 25 hundredths, which reduces down to 1/4. So you could change that 0.25 to 1/4. So that's really minus 1/4 y equals 6. So once again, you could focus in on this system that has now fractions instead of decimals, and you could modify the system, modify the equation so you could get rid of the fractions. So on the top one, you could get rid of all fractions by multiplying everything by 2, and you would get 1x plus 1y equals -2. Actually, no, I'm sorry, -4. And on the bottom, you could multiply everything by 4 to get rid of the fraction 1/4, and you'll get 4x minus 1y equals 24. And now that system's ready to combine and cancel. So you get 5x equals 20, which means if you divide both sides by 5, x equals 4. Once you have one answer, you could plug it into the original equation to find the other answer, or to one of these modified equations. So if we went for the original, you could plug it into the let's plug it into the bottom equation. That'll be a little easier. So we have x, that's really going to be a 4. So let me plug in the 4 right there. X is 4. And then it says minus 0.25y equals 6. Once again, just change the 0.25 to 1/4. So you really have 4 minus 1/4 y equals 6. Let's solve this thing by getting rid of the 4 first, by subtracting 4. You will have negative 1/4 y equals 2. And the final two steps will be to get rid of that fraction by multiplying both sides by 4. So you'll have negative 1y equals 8. So your final answer, when you divide by -1, y equals -8. So your answer number 8 would be 4, -8. Of course, I didn't even assign it, but there it is. So it doesn't really matter if you have fractions or decimals. You could modify the system to get rid of the fractions and decimals.